Hello, Martin. How's it going?
Hey Laura, I am doing alright, how about you?
I am great. I've been really fascinated by how machine learning is being used in so many different sectors these days. It's amazing, isn't it?
At this moment, the stakes are high for machine learning models. Right now, people have very high expectations from machine learning.
Totally. Machine learning has already come a long way. It's going to shake things up in all kinds of industries. Take healthcare, for instance. These models could change how we catch diseases early and give patients treatments that are more precise and tailored to them. The models can scan medical images to spot issues like cancer. And in finance, machine learning is key for spotting fraud. It can help keep transactions secure. The models can also fine-tune trading algorithms, so companies can make smarter investment moves.
That's right. But I've got some concerns. When things get serious, machine learning models are often used to help humans make decisions. These models have tons of parameters, so figuring out how they make predictions is almost impossible for even researchers to fully understand. And an average person who doesn't know much about machine learning will have no idea how these models work.
That's true. But aren't there methods to explain how these models work?
Yeah, researchers sometimes use simpler methods to explain how a big model works by making easier to understand versions of its predictions. These simpler versions help people decide if they can trust the model's predictions. But are these explanation methods really fair? A group of researchers from Massachusetts Institute of Technology checked out some popular explanation methods and found that the quality of these explanations can vary a lot.
I didn't know that. So what does that mean for us?
In the real world, this means people might end up trusting predictions of machine learning that they shouldn't. So, it's really important to improve these explanation models and also make sure we explain them clearly to users. Since there are gaps, users should know they might not be getting the full picture from machine learning and adjust their expectations.
That's a valid point. I guess it's a double-edged sword. While machine learning can bring about so much innovation, we need to be cautious and ensure transparency and fairness.
Exactly. It's not about rejecting machine learning altogether, but about being aware of its limitations and ensuring we use it responsibly.
Absolutely. It's all about balance and understanding both the potential and the pitfalls. So, simplified explanation models can give us an understandable version of what a complex machine learning model predicts. But how do we know if these simplified models are doing a good job?
So a good explanation model maximizes something called fidelity, which is about how well it matches the bigger model's predictions. The researchers from Massachusetts Institute of Technology dug deeper into this. Instead of just looking at the average fidelity for the whole model, they checked out the fidelity for different subgroups in the data set.
What do you mean by subgroups?
For instance, if you have a data set with men and women, the fidelity should be pretty similar for both groups, and both should be close to the overall model's fidelity. If you only look at the average fidelity, you might miss some issues that are hiding in the explanation model.
That makes sense. How did they measure these differences?
They created two ways to measure the gaps in fidelity between different subgroups. One looks at the difference between the average fidelity of the whole model and the fidelity of the worst performing subgroup. The other calculates the absolute difference in fidelity between all pairs of subgroups and then averages it out.
So, they're really digging into the details. What did they find when they used these metrics?
Using these metrics, they looked for fidelity gaps in two types of explanation models trained on 4 real-world data sets. These data sets were for high-stakes stuff, like predicting if a patient dies in the ICU, if a defendant will reoffend, or if a law school applicant will pass the bar exam. Each data set included protected attributes, like gender and race. These are features that usually can't be used for decisions because of laws or company policies, and the definition of these attributes can change depending on the task.
It sounds like there is quite a challenge ahead, with all these complexities to unravel and understand.
After finding these fidelity gaps, the researchers tried a few different machine learning tricks to fix them. They trained the explanation models to spot parts of the dataset that might have lower fidelity and focused more on those tricky spots. They also experimented with balanced datasets, trying to make sure they had an equal number of samples from all the different groups.
Did those strategies work?
Well, they did manage to reduce some of the fidelity gaps, but they didn't completely get rid of them. Sometimes the explanation models indirectly use info about protected groups, like gender or race, that they learn from the dataset, even if those details aren't supposed to be used.
That's concerning. So, even if you hide the labels, the model can still figure it out.
Exactly. It's a bit of a puzzle. It really shows how important it is to understand this stuff well. Fidelity gaps can really mess with real-life decisions.
Absolutely. It's not just about picking any explanation model. It's about choosing wisely and thinking about who it affects in the end.
Exactly. We've got to keep pushing to make sure these models are fair and do what we want them to do.
It's a big responsibility for everyone involved in machine learning.